Despite innovations in traditional data integration tools, gaps remain for organizations that are looking to cut costs and increase computation power by reusing ETL processes being used by their existing ETL applications on Hadoop, or to build new ETL processes on data in their Hadoop data lake. Hello, and welcome to this Bitwise webinar. Finally, open source ETL in Hadoop is here, and it's easy. My name is Nathan Nichols, and joining me today is Shahab Kamal, our EVP of Client Management and Solution Engineering here at Bitwise. Before I pass things over to Shahab, who will be talking about an ETL and Hadoop utility built on the Cascading framework, let me first provide a quick introduction to our organization. Bitwise is a data management consulting and services company. We help organizations meet their enterprise reporting, analytics, and visualization requirements by providing complete end-to-end services for business intelligence, data warehousing, big data, digital, and enterprise applications. What truly sets Bitwise apart is not just our 20 years of experience helping leading Fortune 500 companies solve their most pressing data challenges, but our dedication to developing unique tools that automate and accelerate complex processes, including ETL offload on Hadoop. And here are some of those customers. At the conclusion of this presentation, we'll open things up for an interactive Q&A session, so feel free to send your questions via the question feature at any time during the webinar. We'll do our best to answer all questions, but as always, you can contact us at any time at sales@bitwiseglobal.com. And with that, I'd like to pass things over to Shahab. Shahab?
So, good morning to everyone, or good afternoon wherever you are located. So today we're going to talk about Hydrograph and data aggregation, manipulation, ETL-like option that sits on Hadoop, looks and feels like any other ETL tool, but computes on Hadoop. And it's an open source option for anyone who would like to adopt this as a part of the data lake or the. So to start with, why did we build Hydrograph, right? So the enterprise data challenge. The amount of data, as we all hear every single day, is growing exponentially, and that's where these huge data lakes are coming up. And along with these data lakes, there is an issue, or rather a problem to solve, where we want to include some kind of an option that will help you effectively do the compute on this data, do some aggregations on this data, a tool that sits on Hadoop that lets you pull data inside Hadoop to push data outside of Hadoop and do all kinds of manipulations the way we are used to doing it on our regular ETL tools like Informatica, Ab Initio, and all these other things that we have. The straightforward approach has been traditionally to write MapReduce, to write These, to write any other compute fabric wrapped around in Java. But the problem that inhibits that is our ETL developers are used to these nice little GUIs where they can go and drag and drop a component, function, or property. This is done for them automatically in the compute engine. Changing that mindset. So Hydrograph, as we propose now, is the next generation big data tool. It looks and feels like any other ETL tool, but it executes 100% on Hadoop. So it has its own ETL server. So some of the ETL tools currently are starting to adapt to this technology, but they do the compute on their own ETL server, and the final aggregate file is pushed onto the HDFS file system, and that's not what Hydrograph does. To really benefit from the parallel processing, to really benefit from the massively parallel cluster architecture that Hadoop offers, the actual compute needs to occur on Hadoop. And that's what Hydrograph accomplishes by pushing down the workloads onto the Hadoop cluster, not doing it on an outside ETL server, which could be 4 cores, 8 cores, 12 cores, 16 cores, whereas you have a cluster with 1,000 nodes, which can be like massively and more powerful than what a single ETL server can be. So with that, we go to the next slide and let's look at the architecture of what we have accomplished here. So at the bottom you see Hadoop, Apache Hadoop, and it could be any flavor of Hadoop. It could be Cloudera, it could be Hortonworks, it could be MapR. We are agnostic to that. So as we look to build an ETL-like tool on top of Hadoop, the first problem you were looking to solve is having some kind of abstraction that would let you do this programming in a much more concise manner, in a way where we could build some reusable components, reusable functions, reusable APIs. So various frameworks that were available in the market. We chose Cascading framework as the framework of choice because of its adoption across the industry and also how stable it was. The other frameworks down the road have matured more, and I'll talk very briefly about Spark very soon, but we started building this on Cascading, where because of its the way it is built, you can actually build an equivalent of an ETL function or a component inside Cascading and expose that as an API. Similar things now are possible in Spark. Spark has reached that level of inflection point where it is stable enough. So we are adopting the same thing in Spark at this time, but I'll continue just talking and we'll address Spark down the road. So in Cascading, what it does is it provides an abstraction on Hadoop, and it can generate MapReduce, it can generate Taze, it can generate Flink as different ways of computing your workloads. So we have built reusable components which mimic ETL components like read file, aggregate, reformat, any of these usual things you see in an ETL inside of Cascading and expose them as APIs. The next thing to be done was how together to look like an ETL. So the way Cascading works is you write a Java wrapper. In this Java wrapper, you call these components and functions in the order in which you want them to execute, which in an ETL you do a link between these components in these icons. So exact same thing is done by a Java wrapper. So you write a Java wrapper around Cascading and link these functions together to mimic an ETL function. But this takes you away from writing MapReduce natively because you have reusable functions, and Cascading will generate MapReduce or Taze or even Flink to execute your workload. Based on if there are flags in Cascading you can set, and you can pretty much choose the compute fabric you want to use. But you still have to write the Java wrapper and still need to kind of have your ETL developers learn Java, which is kind of a no-no. So the next thing we did was taking away from writing this Java code. So what we did here was we write on top of this abstraction layer. So Cascading already is an abstraction on top of MapReduce and Taze. We created an XML layer on top of it. What this XML layer does is it has an XML tag for every single component and every single function that you have exposed in Cascading. So if you build a read file, a write file, a reformat, an aggregate, all these things that you've built and in Cascading and exposed as APIs have an equivalent tag in the XML layer, and you can now stitch together all of these APIs, all of these components using this XML file. So now all you do is write one XML file with calling these components in a sequence, and what we wrote is, as you see in the blue stripe, the execution service that sits between the XML layer and the Cascading framework, and it transforms the XML and generates the Java wrapper around Cascading at runtime. So now the business logic of your ETL has been pushed one level above into the XML code. So if you can write an XML stitching together these components, you can pass it to the execution service, which will execute, which will write at runtime generate the Java wrapper around cascading. Cascading calls these APIs and generates MapReduce or Thais, whichever fabric you pick, and executes on Hadoop. So now your workload is starting to look like an ETL. It's sitting in an XML. Folks in the conference today who are aware of ETLs know that every ETL has an XML as its base layer. So you can pretty much export any ETL in data stage or Informatica into an XML file. So the entire ETL logic is actually residing in an XML. So that from the XML point upwards, what we have done is mapped every XML tag to an icon into a UI. So we started developing a UI. It's an Eclipse-based UI, and we created these icons for all of the APIs that are exposed in the cascading frameworks. And as you drag and drop these icons, as you will see in a few minutes in the actual demo, it generates the XML tag for every time you drag and drop an icon in this UI. So this XML file, the XML code that holds your business logic, is auto-generated as you drag and drop the icons in your UI. So it now has become pretty much a UI-driven environment. Like any other ETL tool, you drag and drop your components and functions in the UI, and it auto-generates the XML from the UI. As you save the UI, it saves as an XML. You click a button for execution, the execution service wakes up, reads the XML, creates the Java wrapper at runtime, passes it to Cascading, which auto-generates MapReduce, runs it on Hadoop. So now you have pretty much accomplished the job of creating a UI-driven environment on top of Hadoop that looks, feels like any other ETL tool, but it actually is contained inside Hadoop and runs on Hadoop. So that's what we've accomplished by this exercise. So cascading was one of the frameworks that we've used, and the reason we liked it because it gave you multiple options. You could either run MapReduce, Thais, or Flink in cascading. We also like the stability that Spark has offered in Spark version 2.0, Spark 2.0. So we are now enabling the same UI, the execution service, to now, instead of talking just to cascading, having Spark sit next to it, all these APIs created inside of cascading for all the components, functions, all these things created in cascading have now been being created in Spark and exposed in Spark, so the executed on Spark. The Spark adoption is going to be enabled in the next couple of months. The demo version should be available, I believe, sometime in November, and should be fully live in December. Another point to be addressed here is we started with cascading, and we found out that technology has advanced. We started this journey almost 2.5 years ago, and in two and a half years ago, in 2.5 years' time, we figured out that technology has advanced, and Spark has now become as stable as cascading or any other abstraction layer. It's actually an environment of its own. So we are able to plug in any compute layer, any compute abstraction on top of Hadoop in this environment. Important point to note here is your business logic, as you go on and develop your workloads in the ETL in the UI, are safe from obsolescence. Because if you are looking to take out cascading and now do everything in Spark, it's just a simple execution service that connects to Spark. That's all we build, and it is now swappable. The cascading can be swapped 2 or 3 years down the road. There's some other execution fabric that is even more powerful than Spark and becomes the next big thing. All your code sitting in your ETL is obsolescence proof. you can just swap out Spark at that point of time and just swap in any other execution service. Could be Spark, it could be, maybe Flink 3 years down the road becomes the greatest thing. Who knows what's going to happen? We live in a very fluid space, especially in the big data area. So the architecture of it is such that the compute fabric is swappable, because we realized very early that the Hadoop environment is evolving and there will be obsolescence, and we cannot be tied down by the obsolescence. So this architecture lends itself to adoption by adding more different compute fabrics down the road. Overall architecture of Hydrograph. Looking at the next slide, we look at the infrastructure required. So from a developer perspective, the developer will only see a drag and drop UI on their desktop. There's nothing else that they need to worry about. So you have a Hadoop cluster sitting somewhere in the environment, as you see the right-hand side. And on top of Hadoop cluster, you have either Spark or Cascading. The developer creates and saves the ETL to the code repository, or the developer creates the ETL, and that ETL, the XML part of that ETL, can be put inside a job scheduler. So you can either run in test mode. Normally the developer wants to run the ETL from the UI itself. You can click a button to run it, and it executes either through Cascading or through Spark on Hadoop. Or in the production environment, you can take the XML form of that ETL and put it in a job scheduler and schedule the job to run either on Cascading or Spark on Hadoop. And that's your the whole infrastructure, your environment right there. So with that, let's move to the next slide and look at the features before we get into the demo. The features of Hydrograph. You have a tool layout, you have a menu bar, you have component palette. All these things sound a job canvas, a job console. All these things must sound very familiar to any ETL developer. It has components for inputs, outputs, straight pull, transform. So from a feature perspective, and we will share this with you down the road. This will be available for downloads. You can look at this in detail. But all these features and components, all these things we are seeing in this slide, pretty much looks like a description of any ETL product. And that's what we really tried to achieve, building a regular ETL product on top of Hadoop. On the next slide, the benefits of Hydrograph. From a development perspective, Hydrograph has now taken away the need to write native MapReduce, Phase, or Spark code and given you a GUI-driven environment that can be leveraged to create your workloads. And as I said earlier, it is extensible across MapReduce, Phase, execution engines through Cascading. It can support Flink, also through Cascading. Spark is coming. We are already working on that. We are building the next compute fabric inside of Hydrograph, and Spark should be out very soon, in a couple of months. So it's an extensible architecture, also a swappable architecture. Your business logic in your ETLs should never be open to obsolescence, because as Hadoop evolves, and it continues to evolve, and whatever the next benefit here is, number one, in a nutshell, swappable architecture. Your business logic never goes obsolete. It stays insulated in an XML in the GUI. Whatever happens under the GUI at the execution side is a swappable architecture. We used Cascading to start with. We're going to be using Spark next. 2 years, 3 years down the road, if there's something else, if Flink becomes the best compute layer, or something else comes out down the road, you never have to recode your ETL to adopt to a new compute fabric. So that is the biggest benefit over here. We can go with any other tool we can control that very much. We can go with some other ETL tool, but then you are at the mercy of the ETL product provider if they want to adopt a particular fabric or not. The other benefit here is we have digressed from the regular ETL development lifecycle, and what we have actually done is provided a way for every user to create components that benefit their organization, or a function. So in the traditional environment, it's hard to actually go in and create, you pretty much wait for the ETL product provider to provide you with the function you might be waiting for a while because it benefits you, and writing some workarounds for that. In this case, you don't write a workaround. You pretty much create a component that answers a business problem for you, and it ingests into Hydrograph, and now you have it right there. So instead of, if there's a missing feature in a product, instead of doing workarounds, you create one component and reuse it multiple times. So that's another big feature, which provides value over here. With that, Nathan, why don't we jump into the demo actually? All right. So there you see. So this is what we've been talking about. For all the ETL developers in the room, this looks like any other ETL product. You have a component palette on the left-hand side from where you can pick, drag and drop whatever you feel, an input file component over here. You can pick up the properties for that. You can create the, what they're doing is creating the file path. So this pretty much looks like you're writing an ETL, right? So component palette on the left-hand side. On the right-hand side, you have a job palette. You have a project explorer on the left-hand side where you'll be, creating the versions of your programs, and a console at the bottom where when the job actually executes, you'll be actually able to see the execution over there. So what we're seeing over here is this is where you add the metadata, and it's all prompt-based. Any function you're going to perform. So in this case, a performing a count function. So all of that is actually included right there. It looks and feels like any other ETL product. And then adding more components and linking them through. So what's really happening at this point as you do this on your GUI is it's creating equivalent XML tags in the background. It's for every component you drag and drop, a tag was created. Every time you linked something and all the properties you picked, there are XML tags for those. And an XML file is being stitched together as you stitch together these icons in a GUI fashion. In the interest of time, here's the big ETL that we have created using this environment. And now, at the click of a button, you're going to be connecting to in this case, local Hadoop cluster, but you can connect to a remote Hadoop cluster as well. As it executes, here you see in the console the execution results. The build was successful, and you can test the actual run that occurs on Hadoop right from your GUI environment. And that's why we said earlier that the developer is never away from the GUI environment. The developer will always just be seeing one single console, which is the Hydrograph environment from there. You can, of course, like I said earlier, schedule these jobs by exporting the XML and putting it on a job scheduler, and then it'll run from the scheduler on a predefined schedule. So that was Hydrograph in a nutshell. Nathan, can we go to the next slide? Okay, all right. So we have the benefits and everything. So that's pretty much what we were looking to accomplish today. Talk about the need for Hydrograph, the architecture of the product, the benefits like swappable architecture,